Alright, what's up guys? In this video, we're going to pick up some linear algebra. We're going to be talking about how to find the reduced row echelon form of a matrix. So we got this 3x4 matrix. This matrix here has 3 rows and 4 columns, and they want us to find the reduced row echelon form. So let me just quickly remind you of how we do this. We use a series of row operations to get it in reduced row echelon form. Now remember, a matrix is in reduced row echelon form if it satisfies a number of conditions. The first is that there's a row where every entry is 0, and this row will need to lie below any row that contains a non-zero entry. So if I end up getting what we call a 0 row, where I get zeros for the entire row, well, there needs to be a row with basically non-zero entries above it. So basically all non-zero rows or complete 0 rows need to be at the bottom of the matrix, basically. The second one, I'm trying to think what's the other condition. So the other one is, keep in mind that the leftmost non-zero entry of the row is 1, although some professors will differ. You have to ask some professors on that. The leftmost non-zero entry of a row is a non-zero entry in the column. And then the last one is the pivot element, which is going to be that first entry in the first column and in the first row. It need to have zeros below it. Okay, that's basically the conditions. So what are the row operations? So there's basically 3 of them, but we can actually kind of tweak them a little bit. So remember, there's 3 things you can do. You can swap rows, you can multiply a row by a constant or by some non-zero value. So you can't multiply a row by 0 or anything. It needs to be a non-zero number, and it can be negative, even if you need to multiply a row by a negative number, that's fine. It just can't be 0. Now we can do division as long as we're dividing a row by a non-zero entry. Very similar to how we can multiply any row by a scalar, as long as it's non-zero. And we can even add and subtract rows, but in order to do that, we would have to add and subtract rows after multiplying rows by another non-zero number or another non-zero entry. So those are some of the just basic row operations. Okay, so in our particular circumstance, any rows containing full zeros need to be at the bottom. So you just have to determine what's the appropriate row operations to do. So we got this matrix. So look, we have 4s everywhere. 4s basically down the columns and 4s all around the all in the rows. So we want to attain 1 here, which would be our pivot. So the best thing to do in this particular circumstance for row 1 is to multiply row 1 by 1/4. What that's going to do is going to give me a 1 for that entry. So let's do that. So let's multiply row 1 by 1/4. And what it does is it'll give me 1 there. Okay. So since we only got 3 rows, we don't need to make an unnecessarily big matrix. So since we only multiply row 1 by 1/4, I did not touch the other rows. So the other rows should still contain 4s. So if I multiply all of these by 1/4, this just becomes 1, 1, 1, 1, because we want a 1 there, which is our pivot, and we didn't touch the other rows. So it's going to be 4, 4, 4, and 4, and then another 4, 4, 4, and 4. Now remember, I did say that we can subtract a row as long as we're multiplying the respective row that we're trying to subtract from by some scalar, as long as it's non-zero, of course. So in this particular circumstance, we know we need to obtain zeros in both spots where this 4 is, because we need to have zeros below the pivot. So what we can do is we can subtract row 2 by multiplying. No, what we can do is we can multiply row 1 by 4 and then we can subtract row 2 from whatever we get when we multiply row 1 by 4. And what that allows us to do is obtain zeros in this second row here. And of course, we'll have a 0 below the pivot, but we also need 1 down below as well. So let's do the operation. Let's subtract row 2 from 4 multiplied by row 1. And so in this particular circumstance, so we still got our ones in the first row. What that's going to do, the operation that we just did, is going to allow us to obtain zeros in our second row. And remember, we didn't touch the third row. We left that alone. Now we're not done because we still have a 0 below the pivot, but we need a 0 there as well. Okay, and this is a non-zero row, and as you can see, or not non-zero row, excuse me, it's a 0 row where we have all zeros in the second row. And notice how we do have non-zero entries in the row that's above it, so we're on the right track. So we need a 0 there. So again, what we're going to do is we're going to multiply row 1 by -4. And then what we can do is, after we multiply row 1 by -4, or actually we can just multiply it by 4. We can subtract row 3 from that, and we'll end up getting zeros for the entries down in this last row, which will also be exactly what we need as well. So let's go ahead and do that. Okay. All right, so we still got the ones in the first row. We now still have our zeros. We didn't touch the second row, and now we're going to have zeros in the row that's below that one as well. And so now we essentially have our matrix here in reduced row echelon form. So that's the answer. That's how you put it in reduced row echelon form. So we'll write our final answer down here. And we'll say RREF. It's going to be equal to the following: 1 1 1 0 0 0 0 0 0 0 0. So that's the reduced row echelon form of that matrix. Okay, so doing this takes a little bit of practice, and you got to get really comfortable with using the row operations and kind of understanding what to look for as it pertains to row echelon form and reduced row echelon form. All right, so that's going to be it. I'll see you guys next time.